GW Phoenix, another rant. What do we want to talk about? A short topic or a long topic?
Sure.
Short topic? Okay. Let's talk about how the universe works.
Short as it gets.
That is as short as it gets. It actually is. What we have to do is we have to go down as far as we can observe at this point in time, and that is, it's actually the electrons and the neutrons on the atom, but yes, essentially it is the atom. We're trying to get to the higgs-boson.
Which we actually observed recently.
Ooh, nice. But we look at that, and what we have, of course, is we have one tiny little speck of energy with energy going around in electrons, protons, neutrons. And so one piece of energy and things going around. Now, if we look at this, and we're going to go further out from that view, but remember that definition right there. We have one piece of energy in the middle with pieces of energy going around. It's mostly empty space. Now, the atom makes up molecules. Molecules make up items. Now, because we're mostly empty space, we should be able to go through anything that we touch. But we have electromagnetism creating a sort of a force field. That's what the atom does. The atom's mostly empty space, but with its vibration, it creates a vibration that keeps it from falling apart. Yes. Now, to understand the universe, we understand that we have a piece of energy, things going around it, that creates sort of a magnetic force field that keeps everything together or keeps everything apart. And now let's go way back and look as far back as we can. We're going to look at... No, not as far back as we can. We're going to look at our solar system. We have one piece of energy in the middle surrounded by pieces going around. Now, many scientists have always have pawned the question, if evolution is real, where are the larger particles? Everything has to get bigger. The only problem is when it gets bigger, it's made up of the things that are smaller. So the sun is a representation of the atom. The Earth, a
Representation of the proton.
Oh, let's say proton because it's positive. Good.
The other reason is because isn't the neutron usually the thing that is in the middle and the protons rotate around them? Neutron?
Actually, one goes in one direction on the inner section, one goes in the other direction on the outer section.
Okay. So they're opposites, but they constantly spin.
Right. Constantly spinning. And now, with how all this works, like I said with the atom, it's sort of a force field of electromagnetic vibrations that keeps it together. That's also what keeps our solar system together. Only we measure it as gravitational units because, that's sort of what it is. We have a large piece of energy that creates a warp in our space-time, making sort of a funnel that we go around in. And if we were to look at it, it would almost look like there were belts going from the sun to each planet as they go around, like a planetary grid. And then we have the galaxy, which is much more of the smaller units, the solar systems, going around a large black hole, which is, as far as we know, the largest, most massive thing that exists at this point. We haven't been able to observe anything bigger, but of course we have been having all these questions about wormholes and dark matter. Is that what they?
Matter and white holes.
Oh, white holes. That's an easy one. I mean, a black hole has to go in. A white hole has to come out. It's pretty much the same thought as a wormhole, only you're getting crushed at one end and spit out like diarrhea at the other, which kind of sucks. But essentially, that shows where the entire universe is. Then you have to think of it in a different sense, because everything that I mentioned there has electromagnetism. So electromagnetism for the atom, and then you get up to the larger gravity, which we have studied and studied and studied, and really gravity is an electromagnetic current that keeps us in place. That is constantly producing an electromagnetic field. The Earth's electromagnetic field is 7.35 megahertz. And unfortunately, they went and they screwed us up when they did cell phones, because they did those at 7.37, I believe. So it was just off enough to go and screw things up, but not far off enough to be really noticed by too much. That was actually found out by Nikola Tesla, written down in some of his stuff, because he was trying to find a way to go and use that vibrational, energy to go and give everybody free power. That's what Warcloth was for. So looking at it that way, we of course know that with things like magnets, there's a permanent source of magnetism there, which can be utilized in one way or another to perform a function. Unfortunately, most of the things that have to do with creating power have been swept under the rug in all of our past. I'm not going to talk about that section, because that goes into the long one about where war starts, where modern war starts. But as we look at it, we look and see that it's an electric style universe that pulls everything around, and it's all electromagnetism that keeps everything together. All right. So, now that you've heard my side, let's hear some thoughts.
Why the universe is what it is. The universe is ultimately a reflection of itself, because we have no idea technically what the universe is, what the what the existence that we are is. We could technically be, we could be a molecule or an atom for a much larger creature. We don't know where we are. We don't know what we are. We don't know why we are. Therefore, we could be anything.
We could be a cancer on some cell somewhere in existence, and this guy's scratching his nuts, and there we are.
Yeah.
I like that. We could be an air molecule. Oh.
Well, because
maybe we're who's.
Well, because like you were saying, with the idea that an atom is an atom has the protons and neutrons going around it, so it's something that has something circling something.
Mm-hmm.
Therefore, you look out farther, you look at the solar system. You have something that is circling something.
Mm-hmm.
Therefore, an atom is the same thing as basically the Earth and the Sun.
Exactly,
therefore, the smallest little particle that we can observe as beings is a reflection of the thing that is greater than what we can actually observe the whole thing of.
Right. I sort of see it like the metric system, right? Because you have millimeters, decimeters, decameters.
That was just kind of random.
No, I mean, really, you have the...
When you first said it, it was random until I died because I'm drunk.
Oh, okay, cool. Awesome. You have millimeter. Well, you go down and you have like nanometers, and and then you have you get way up. We know very, very well millimeters, centimeters, meter. the kilometer, and that's sort of how the nanometer is the atom. The kilometer is the solar system. In the middle, there's so many other things that you can observe that have the same process within them.
Yeah.
And then the oh my god meter, whatever that is, that's the
universe.
no, that's the galaxy, because the galaxy is the same thing. The universe could be something even bigger.
Yeah. Actually, I thought about this when you were talking about how everything works and spins around itself.
Mm-hmm.
It's basically like a drain.
Yes, it's a vortex. The electromagnetism is what we observe as a black hole. That's the extreme showing of electromagnetism. Mm-hmm. And with the black hole, all that is a torus. Torus is a funnel, a cyclone that goes in, eats itself, births itself, and goes back in. Mm-hmm. But we can't observe both sides of the black hole. Not at the same spot, because it's not in the same spot. You have one side as a black hole, and somewhere where we don't know where it is, there's a white hole somewhere. Mm-hmm. And those two are connected. Yep. But if you pull them together, all that they are is you have energy going in one side and then coming out the other.
But
then going all the way back around.
Isn't that the same idea of a wormhole? Is that it has an exit point and an entrance point?
Well, yeah.
So effectively, that's why the astrophysicists and such are thinking that the black holes are actually wormholes, is because we don't know what happens to them. And also, here's a thought process I've had recently, because of reading about a decent amount of different science stuff and everything. We have for the last, I think since 1994, every once in a while, not terribly often, but every once in a while, and becoming more and more frequent recently, been receiving radio signals from somewhere deep in space that we can't, it's something like they estimate 9 billion light years away. We don't know. It could be the fact that our own radio signals coming from Earth are going through our solar system into our black hole and coming out as from the white end of the hole, the other end of the wormhole, and coming back to us. Because literally the radio signals that we're getting are milliseconds. And it's like 001.
What the messages are 001?
Yes. So, something like that. I don't remember the exact one, what it exactly is, but it's one of it's just the basis of what computer communication is. But we've been getting them much more frequently recently than we did in 1994, and that could be the whole cell phones, TV, everything that we have now sending so much out into the universe, being eaten by the black hole and sent back to us.
It could be, but then that, of course, is also assuming there's nothing else in the universe.
Well, yes, that's assuming there's nothing else in the universe, but
that's what we do when we assume.
Yeah.
But then, of course, there's the question of, is there something natural that could create that? Because we've already found that Saturn, Uranus, Jupiter, every planet and every...
It's actually Uranus, not Uranus. I know that very well because my uncle yelled at me and grounded me for about 2 weeks because I said Uranus to my cousin, actually talking about the planet. So the name of the planet is actually Uranus.
Whatever,
Uranus.
I don't care. I don't care. It's your anus. Shit.
I got in a lot of trouble for that one a long time ago.
But every single object has a vibration, a radio frequency vibration that comes off it. Mm-hmm. And there is a possibility for something like a neutron star, which is, beep, 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 to actually go and give us a false signal. Mm-hmm. There's also a possibility that maybe, someone thinks that we're ready. I don't know.
We don't even know exactly where it's coming from. We estimate it's 9 billion light years away, which we don't even, at this point in our lifespan as humans, we've actually recently questioned whether we actually know what the distance of a light year is. It may have been miscalculated.
No, they know that it was miscalculated. It's a constant that's not actually constant.
Yeah.
If you look into the physics books in, let's say, 1978, 1979, 1980, each one got recalculated and was different. But in 1986, I think it was, they went and they averaged it so that it's always this number. And in doing so, they took out the question of whether it goes faster or slower. To be completely honest, all that white light is part of the entire thing, which is when you have an item with something circling around it, it creates a vibration. Vibrations that happen sequentially are a wavelength. Now, if you look at the wavelengths, let's start from ones that we can perceive easily. We have sound. Sound is an easy one to perceive, especially looking at a sub and it's doing one of those slow ones, womp, womp, womp.
Well, plus sound is what easily perceived because, as human beings, because after we're out of the range of something making sound, we can't hear. We look up into the sky and we see this giant ball of light that we know is thousands of light years away, or however, we don't know exactly how long that light is taking to get to us.
What is the light?
The light is the energy from the sun.
What is energy?
It's everything.
What is energy?
Everything.
Come on.
Atoms, molecules, yes.
No.
Vibrations.
Yes! Energy is vibrations. Vortex Uber. The gray. Yeah. Don't hurt.
No. Take your hand right here on yours and slowly squeeze and move your just your fingers right there. Feel that muscle on the outside of your hand. How does it hurt when you squeeze it like that? You massage it a little bit.
Not really.
That right there.
You popped my wrist, but I don't think you did anything else.
No, the muscle right here, I was stretching it out a little bit. If you massage this muscle right here, this muscle when it's tight, it actually affects your shoulder. Can you pause that real quick so you can smoke?
A smoke. Alright. Pause.